Hello everyone and welcome back. In this lecture we are going to see how you can use filter expression in your search query. Filter expression provides value-based criteria for including or excluding content before query execution, which means that you can specify filter conditions on individual fields. Now field definition must be filterable, so you have to check mark filterable as yes while creating it. Now filter is specified using OData filter expression syntax. So if you want to learn more about OData filter expression, I've pasted a link here. You can click on it and learn more about how you can provide filter expression in OData format. We're going to see a few examples. The most important point, a filter succeeds when it is an exact match. So unlike in search query, you still get matches even if your search query does not match exactly to your document. In case of filter, you will get result only if the match is exact. Now you can use filter expression when using search query to find near me geospatial search, which means you can provide geological latitude longitude coordinates and provide queries something like the last example down there. So you can find items which has a geographical location within specified distance to the latitude and longitude provided in the query. If you want to use Facets navigation, you will need filter expression. In search query, you cannot use Facets navigation. And also other examples include when you need to restrict users to allow them to see just the documents they have access to, you can use filter expressions. And also to do filter based on number searches, because in search query, because numbers or integers are not searchable in your index schema, you need to use filter expression for them. You can make the number fields filterable and then run your filter query. Now we're going to see some of these examples. So we're going to see example where our record timestamp is greater than a particular timestamp. We will do exact match for our record ID using equal operator, and then we will also see how you can find items in your index which are certain amount of distance away from a given latitude and longitude point. So let's go back to our Postman and see these examples. So back in my Postman, I've created another example request for filter. Everything else remains the same. We are using the same docs search API endpoint. We are using the same management API key. It's a post request. And inside the post body, we have the same attributes that we are sending as JSON body. Now when we are using filter, search does not make sense, so we are keeping it as star. For my first example, we are going to look for all the record timestamps which are greater than this timestamp, right? So greater than is one of the operators available in filter query. If you go to the filters in cognitive search documentation, you will find detailed OData filter expression syntax information. And if you scroll down, you will find different filter patterns that you can use. We are just seeing some of the examples. For example, if you want to do case sensitive match for your strings, you can use search.isMatch scoring. And if you click on OData filter expression syntax, you will find different expression examples. So these are the operators available: equal to, not equal to, greater than equal to, less than, and less than equal to operators that you can use. You can use boolean literals like true and false. Now some of the geospatial functions that you can use are also mentioned here. If you want to do search like full text search operations, you can use search is match and search is match scoring functions. There are some logical operators like and, or, not, along with comparison operators. Now you can combine hundreds of clauses together, but there will always be a risk of exceeding the limit of the filter size that you can put in. Just make sure that you don't hit that limit, but otherwise you can still have hundreds of clauses combined together in your filter expression. And then there are a few examples mentioned in here. So coming back to our filter expression, if I search for this, I'm getting about 9231 items because we uploaded everything at the same time, so we're getting most of the items which has timestamp greater than this one. Now if I change it to 55, let's say, now I'm getting nothing. So there's no item which is having a timestamp greater than this one. Let's say if I make it 65, I'm still getting 9231. So most of the items have timestamp equal to or greater than this timestamp. Moving to our next example, let's search a record ID. So I'm searching for a record ID. This should be an exact match and we should get just one item back. Let's search for it. So we got just one item back, and because we have just one item, search score is 1, and here's the ID. So in our next example, let's do a geolocation search. I have copied latitude, longitude for one of our items in the index. Now I want to search all the items which are 0.001 kilometer distance away from this one, the one I'm searching from. And you can use geo.distance function for this. So we know that in our index we have geom as the geography point for different addresses. Let's search it. And we have got just one output because the distance is so less that we most likely got the same item back. And you can see it's the same latitude, longitude, but if I increase the distance to 10 kilometers, I will find a lot of items, right? So I'm getting so many items back. If I decrease it to 1 kilometer, I'll reduce the number of addresses to 891. So here we're getting all the addresses which are 1 kilometer in range, in distance of this latitude and longitude point. So those were a few examples of filter search. Now you can also include some facets if you want. To get back facets, you just need to define fields that you want to get back as facets. Let's say I want geolocal area to be returned back with my result. So I can just define it here. Let me put that in double quotes and search again. This needs to go under fields, right? Now along with our results that we are getting, the total count 891, we are getting some classification as well. So facets are nothing but classification based on one or other fields. So we know that in our result, out of 891, 730 addresses are in downtown and 161 are in Fairview. So you can use facets in your application to further filter down your result set. People can choose these from, let's say in your UI, you can have a checkbox. People can select downtown there and they will further see only 730 items. You can have as many facets described here. So let's say I want standard street as well. Let's search it, and this time we got further breakdown of our addresses in the result. So we know that 143 are on this street, 64 are on Hornby Street, etc. So that was the example of facets and how you can use them. Thank you, and I'll see you in the next one.